Does that z require?
Y argument of t by finding y of t and y prime of t and taking t goes infinity. That's the idea. Okay? No final value theorem here, guys. Right? So, step one. What's that? Finding z prime bar, right? What is my input? Z prime, a sine omega t. Look at the dictionary. Right? It's going to be a omega over s plus a omega squared. So, equals dictionary, the expanded dictionary, a omega over s plus a squared plus omega. Sorry. That was bad. Sorry, there's a correction here. That's e to the minus at sine omega t. So a is 0, so it should have been s squared plus omega. So make corrections, e to the minus 80, that a is from the e to the minus 80. So a is 0 here. This just have sine omega. So the little a is 0. So the a, of course, factors out. Okay, z prime of t here. Let me write first. Z prime of t is a sine omega t. Therefore, dictionary z prime bar equals a omega over s squared plus omega. Sorry for erasing and rewriting and all. But there I wanted to be crystal clear.
So it says up there to obtain y ultimate prime of t and then y prime of t. And finding y prime of t.
By finding y by taking the limit and taking t goes to
I think
infinity.
which is both prime, but that doesn't just have to be.
Yeah, it's prime. Everything is deviations you're doing, so that means we're starting from 0. Implied assumption rule. Okay? So, step 2. Y prime bar is going to be the transfer function times z prime bar. In other words, g of s times a omega over s squared plus omega. So, g of s is going to be something in the numerator over s minus 0.41 to the power 1, s minus 0.2 to its multiplicity, s minus 0.q to its multiplicity, e to the minus ds times a omega over s squared.
You lost me.
Plus or minus.
What just happened?
What is the transfer function? The transfer function is some polynomial in the numerator or a polynomial in
Oh,
the
okay, you're
denominator.
just not showing it. Okay,
And that
gotcha.
can be factored s minus pole 1 times s minus pole 2
Okay.
and e to the minus d. Okay? That's what we've been doing in the class many times,
Gotcha.
right? And can immediately write that y prime of t is 0 for t less than t. And of course, I'm not interested in that because I'm looking at long times. This thing goes to infinity. And it's going to be h bar, h of t minus d for t greater than d, where h bar is everything without the e to the minus d. So h bar is going to be something over s minus p1, its multiplicity, s minus pq, its multiplicity, a omega over s squared plus omega squared. What partial fractions experiment we should do for that? The regular one?
Don't we need Excel for that?
I'm not going to do that whole thing. I'm just walking you through. It would have been a tough one. Okay, I'll admit that. It would probably have taken you a lot of time to do it. I'll just walk you through it. So, what partial fractions expansion do? So h bar equals. Do I use the regular partial fractions expansion? All my, first of all, some of the roots could be complex here, but what are the denominator roots of this? Put s squared
Plus or
plus
minus.
omega squared equals 0. What is s equal to?
Plus or minus I equals 0?
Right? Complex conjugate pair. So we shouldn't do the regular partial fractions expansion. We should be doing the alternative partial fractions expansion. Okay? But in this case, actually, in this case, it's going to be, to get this proof, we want to use the regular partial fractions expansion. In this case, we do want to use the regular partial fractions expansion, not the alternative one. It's easier, you can do it either way, but, okay, I don't want to spend too much time, but h bar is going to be what? Some constant over s minus p1 plus we have all the part that comes from this part, and I will have plus some constant, let's use, I don't know what sinus we use, e over s minus I omega plus f over s plus I. Okay? All right. So, what would be h of t? H of t would be C11 e to the P1t plus C cubed t to the C cubed e to the PQT plus e to the I omega t plus f e to the minus I omega t. Right?
Then you use the cosine and cosine.
I'm not going to go sines and cosines. What do I want to show? I want to show that I will get something like that, so I'll just walk you a little bit through. So h of t minus d would be c11 e to the p1 t minus d, and so on, cq, cq, t to the cq, e to the pq, t minus d, plus e to the I omega t minus d, plus f e to the minus I omega t minus. With me? So, this is the partial fractions expansion. The normal partial fractions expansion. Okay? So, the inverse of that, using the dictionary, e to the root t. Okay? And remember, okay, so here there will be also a coefficient, I didn't do it quite right, over some, over, it's t to the cq minus 1 factorial.
Can you write that down?
Anyway, guys, whatever that is, I'm going to kill it right now. What happens as time goes to infinity? I'm talking about a stable system. For a stable system, what are all the poles? They have negative real part. As time goes to infinity, all those have e negative t. E negative t to some power. I don't care how big the power. T to any power, e to the negative t. As t goes to infinity, becomes what? 0. So whatever this thing is, as t goes to infinity, h of t minus d goes to, all these guys disappear to e to the I omega t minus d plus f e to the I minus I omega t minus. That's why I didn't bother to, here there's a factorial, remember dictionary is something, t factorial something is that. So, yeah. Mika.
So how does that relate to so you don't do partial fraction decomposition?
I did.
Oh, what?
Here's the partial fraction decomposition. But all those guys would have an e to something negative t. So all those guys, as time goes to infinity, disappear. All those guys will not be there for the ultimate response. The only thing that doesn't have is these two guys have 0 real part. These two guys don't disappear as time goes to infinity. Every other disappears as time goes to infinity. That's the key. All the guys, everything that comes from the transfer function disappears because all the poles of the transfer function have negative real part. Robert and Robert, how do you? Okay? So I just put some numbers here, I don't care. Something, just put dots. I shouldn't even have to put C's, dots. Okay? All those guys disappear as time goes to infinity. Whatever those dots were, I don't care. With me? David, okay? Thank you.
For the h of t minus d, does the t to the squiggly cube be a t minus d? Or no?
Oops.
Just quickly. Oh, yeah. Yeah. Yeah, that absolutely. Yeah, let's make that connection. Yes. Absolutely. Thank you, Mike. But still it disappears, okay?
Yeah, I just
What can I say about E and F. Remember, what is that G bar? That H bar. That's the part of G without e to the minus ds, right? So we have G of S equals H bar e to the minus ds. Okay? So that G bar, so that H bar right? So, since the only thing that survive are E and F, can someone give me, and they are all highest power, right? Each root has multiplicity 1. That's the highest power coefficients. So which method should work for getting E and F? Quick and easy. The left-hand side is H bar, which is G of S e to the ds. Who can tell me what E is equal to? Tell me. Oh, sorry. I forgot to say something very important. That is, H has G times, I made a mistake here. That's, yeah, G of, that's, okay, sorry. I messed it up. H, what is H? Is the part of Y prime bar, and Y prime bar has also Z prime bar. So H, okay, Y prime bar is G of S A over S squared plus omega squared, right? That's what. And that, so that is going to be, let's write H without the time delay, let's say G is something times e to the minus ds. With me? G, let's say G is G without d of S times e to the minus ds. Rewrite G like that. So Y prime bar is G without the d part S e to the minus ds A S squared plus omega squared. So what is H bar? It's going to be the G without delay S, A over S squared plus omega squared, or G without delay S, A over S plus I omega, S minus I omega. With me?
No.
No?
Like, are we going backwards?
I'm not going backwards. So everything is good up to here. Everything is good up to here. Okay? And now I'm going to try to find what E and F. We know that H of t minus d is going to be E times this plus F times this. And I'm going to try to find E and F. And so what's the left-hand side is H bar to the top of fractions expansion. I want to bring it in a form where we can use the quick and easy method. So what is H bar? Well, Y prime bar is G times A over S squared plus omega.
Should be A omega.
Oh, A omega, thank you. Yes. So let's rewrite G, which is something times the delay.